the qualitative part of it, 2017, the qualitative analysis. This is the practical that gave most of the students a very big challenge, because here, unlike other years, they were supposed to write the test for themselves and then give the observation. They write. So so many people or students did not get this right, because actually they were supposed to write the test. If somebody does not know the test, then the observation cannot be made. So let us look at the question itself. You are provided with solid K, aqueous ammonia, aqueous sodium sulfate, dilute nitric acid, and then wooden print. Solid K is suspected to be lead 2 carbonate. So you should understand the behavior of carbonates with the acid. Whenever you add an acid to a carbonate, you expect effervescence. So if you don't understand those kind of information, then you are likely to be left out in this. So from the reagents provided, select and describe 3 tests that could be carried out consecutively to confirm if solid K is lead 2 carbonate. Write the tests and expected observations in the places provided. So the first thing you want to do is to test whether indeed when you add HCl to the solid provided, it will give effervescence. If it will produce effervescence, then you are likely to say, yeah, this one could be the lead carbonate. So the first test is that you add you can add 10 centimeters of to the you can even start it at 2 solid K in a test tube. Add about 10 centimeters cube of dilute nitric acid provided. Dilute nitric acid provided. And then you retain the reaction. So you should tell that they retain the reaction, the mixture. Retain the mixture for tests. For tests 2 and 3. So when you added 10 centimeters of dilute nitric acid to solid K, what did you see? If indeed it was a carbonate, then you expect what? Effervescence. Effervescence occurs. Another observation is that a colorless gas, because you are given a wooden sprint, now you will use that wooden sprint. This gas, will it extinguish the wooden sprint, or it will rewrite, or what will happen? So a colorless gas, we expect carbon dioxide to be produced. It is the carbon dioxide which will cause effervescence. Therefore, we know carbon dioxide does not support combustion. If you introduce a burning sprint, it will go off, it will extinguish. Therefore, a colorless gas is produced. A colorless gas that extinguishes a burning sprint. A burning what? Sprint. Let us go to test number 2. So with that one, we have, these are the things we need to confirm, that we know that if I had this one, will produce effervescence, and effervescence is produced because of the carbon dioxide gas that will extinguish a burning sprint when it is introduced to it. Test number 2. Now we have the reagent aqueous ammonia and then sodium sulfate. You have seen most, you cannot test for, you cannot use the aqueous the sodium sulfate before you use ammonia. So most ammonia will come before the sodium sulfate. Therefore, we now take about 2 centimeters of this mixture to about 2 centimeters cube of the mixture in Roman 1 in 1 above. Add to about 2 centimeters cube of the mixture in Roman 1 above, add ammonia solution, okay, aqueous ammonia solution, dropwise until in excess. So because we are expecting lead, what happens when when ammonia is added? Suppose lead was in that solution, what will ammonia do? Ammonia will form a white precipitate, and that white precipitate will be insoluble in excess. Remember, ammonia, when you add ammonia dropwise, a white precipitate is formed, and in excess the white precipitate dissolves to form a colorless solution that confirms zinc ions. But if it does not dissolve, then there are other ions inside, like aluminium, like these others. So here the observation is that white, because we are suspecting lead, so lead is among the amphoteric. So a white PPT is formed, insoluble in excess. Yeah, because we know that if it was lead, it will form a white precipitate which is insoluble, that is ammonia. But if it was zinc, it will form a colorless solution in excess. Let us go to test 3. Now, to about 2 centimeters cube of the mixture in Roman 1, add 2 drops of aqueous sodium sulfate. We are adding sodium sulfate. We expect that the sulfate will combine with lead to form lead sulfate. Therefore, here you are expected to write a white precipitate. White PPT is formed. White PPT is formed. Now, up to that point, you have confirmed that this one could be actually lead carbonate. Now, part B, carry out the test described in A using solid K and record the observation and inferences in the places and the spaces provided. Now here the students were required to now carry out the experiment using the tests the test they have described. So they were supposed to first, so you see in the first one, solid K in a test tube, add about 10 centimeters. So that is now what they were supposed to do it now practically, so that now they could make this observation. So majority they did not understand that. I think that's why they failed very much this year, the practical part of it. So here they were supposed to carry out this now practically. Remember, this one was just being written, showing the understanding you have in these things. But here they were supposed to do it, and then state the observation and then the inferences. So here the observation was, as we have said, that effervescence occurs a colorless gas extinguishes a burning sprint. So you are supposed now to give the inferences of what you have observed. So definitely, if an effervescence occurs and a colorless gas is produced which extinguishes a burning sprint, then that tells you that it is a carbonate, and then you write the CO3 2- present. Test 2, what was the observation? Now you do the test 2 using the procedure that you provided. To about 2 centimeters of the mixture above, add ammonia solution dropwise until in excess. Because now this one you are doing it practically. What will you observe? What was the observation? The observation was that a white precipitate, a white PPT that was insoluble in excess, that was insoluble in excess. Now here we would want to challenge, because here if it was insoluble in excess, from the amphoteric we know we have the ZAP, the zinc ions, the aluminium, and the lead ions. Yeah. So because a white precipitate was formed which is insoluble, inside here could it be so many? So here could it be lead? Yes. Could it be magnesium? Could it be barium, aluminium, and the rest? But we are going to cancel some out. Remember, we are going to say that aluminium carbonate, why I'm not going to allow aluminium, or aluminium carbonate is not there. Do we have aluminium carbonate? Because we have said that carbonate is there. Aluminium carbonate does not exist. Therefore, aluminium is taken out. Right? Also, we can also, also what I'm leaving out calcium, 2 ions, calcium ions. Calcium ions are also present. So, what we are going to say, calcium cannot be precipitated by a weak base ammonia. Therefore, calcium ion will be disqualified from there. So, what we are going to remain with is magnesium 2 positive and lead present. Magnesium 2 positive, lead 2 positive present. Test number 3. Now, when the test was done practically, solid decay proved that no, when we did this, when this was done, to about 2 centimeters of the mixture, that was solid decay that was dissolved, add 2 drops of aqueous sodium carbonate. Here we say the white precipitate is formed because we didn't do the experiment. But on doing the experiment, this was the observation. No white PPT was formed. On doing the experiment, there was no white PPT. So if there was no white PPT, then it means lead ions were not there. Because if the lead ions were there, they could form a white precipitate. But since, so here we say magnesium 2 was present. Or you can say lead 2 positive was absent. It is acceptable. Was absent. So these are the observations on doing the experiment using the the solid K, using the solid K. This one, the students were required to show that they know what happens when we have a carbonate. Thank you. Let me take you to the last part of it. The last part, we had the organic. The last part of it, we had the organic. You are provided with an organic compound. Here you have been told that you have organic compound solid M. Right? That is a very important information. You are provided with an organic compound solid M. Carry out the following test. Record the observations and inferences in the spaces provided. Place all the solid M in a boiling tube. Add about 10 centimeters cube of distilled water and shake. Retain the solution for the use in the procedure B, Roman 1, Roman 2, and Roman 3. So, here we want to state the observation. Did the solid M dissolve in water? Yes or no? So, the solid dissolves, forming a colorless solution. Since we know it is an organic compound, then now we say a polar organic compound. Yeah, a compound which is organic and it dissolves in water, forming a colorless solution. It means that that compound is polar. Because water is polar, therefore it has to mix in another polar organic compound, another organic or polar substance. Use about 2 centimeters of portion of mixture in the test tube for tests 1, 2, and 3. So, to the first portion, add all solid sodium carbonate provided. I have always told you that whenever you are adding sodium carbonate, this is a carbonate. If the solution is an acid, you will expect a effervescence. If the solution is not an acid, you will not see effervescence. Therefore, you know what to say. So here, solid carbonate, you expect effervescence or no effervescence. So here in this case, there was no effervescence. There was no effervescence. If there is no effervescence, it means that the organic compound was not an acid, was not an alkanoic acid. So therefore we say RC, this is the functional group of alkanoic acids, was absent. If this one disappears from your mind or you forget, you can write the hydroxonium ion, it is acceptable. Absent. You can say this absent. To the second portion, add 2 drops of acidified potassium permanganate. Warm the mixture. Remember, acidified potassium permanganate is purple. So the purple acidified potassium permanganate is decolorized, meaning that the purple color changes to colorless. The purple color changes to colorless. That's what it means. So if that happens, then it means that there is a double. That organic could be a double. Could be an alkene or an alkyne. Please avoid writing alkene or alkyne in words because they usually ignore that. Or an alcohol is present. Or an alcohol is present. This one we write all of them, the 3 of them. They could be present when purple acidified potassium permanganate is decolorized. Then these 3 are expected or are suspected to be there. To the third portion, add about 2 centimeters of acidified potassium dichromate. Heat the mixture to boil and allow to stand for about 2 minutes. Then the color changes from orange to green. So that confirms that the alcohol is present. That confirms the alcohol is present. So how else can you state it to observation? You can say that the orange, the way you can state this observation is that the orange acidified potassium dichromate, the orange acidified potassium dichromate changes to green on warming or on heating, whichever, on warming. So this one is present. Thank you. I want to appreciate your support. I want to appreciate your support very, 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 very. Please, thank you for your support.